Today we are going to look at problem solving with quadratic functions. Our procedural fluency is going to focus on using technology to solve polynomial equations, particularly using the polynomial root solver. That's what we're going to be looking at for today. Our conceptual understanding is modeling real-world constraints and sort of making sense of the question and applying quadratic models to access real-world contexts. So first off, our procedural fluency. We need to be able to solve this using our graphing calculator. So grab your graphing calculator. Okay, so here's my graphing calculator. Questions. So what we have here, we have polynomial functions. Now polynomial functions, these are polynomial equations. Polynomial equations are going to have more than one solution. They're going to have more than one solution. N-solve is great. It only gives you one solution. We will look later in the course at how to get multiple solutions out of N-solve. But for polynomials, your best and quickest technique is to use the polynomial root solver. So I'm just going to start off with a nice fresh calculator. I'm going to press 1 for new, press a no to save. Always add a calculator page, and in fact we're going to use the calculator page for this. So first up is what we want to do is we want to press, get your calculator warmed up, press menu. This is obviously algebra, number 3, and we want the polynomial tools, number 3. And then we want number 1, find the roots of a polynomial. It's going to ask you the degree of the polynomial, how many roots it's going to have. So if we look here on the first one, we can see that this is going to be a second degree, so it's already set for that. And then we click OK on this. It has a little model at the top here of how the function looks. a2x squared, a1x, a0 equals 0. And then there's a2. So the first constant is the coefficient of the x squared term. We put 2. The quickest way to tap this with your fingers is to use the tap button to go down each time. And the next one. It's much quicker with your fingers. This one wants to be a 2, and this one wants to be a negative. So make sure you use this negative under the 3. So we want negative 12. And simply press OK and press Enter. So this has 2 solutions. X equals negative 3, x equals 2. Have a go now at solving the next 2. What did we get for our solution to the second one? Only give me 0.485. Is that correct for 3 significant figures? Yeah. Okay, for C. Ready? Okay, let's take half one. 2 over 3. 2 over 3. 2 over 3. 3 over 2. Okay, so we have a problem-solving question on this one. The graph of a quadratic function has the y-intercept 10, and 1 as its x-intercept is 1. The x-coordinate of the vertexes of the graph is 3, and it is a polynomial function of the form y equals ax squared plus bx plus c. Have a go now at solving this problem. Sketch the information that you have into a graph first to build up a picture and an idea of what you know and what you don't know. And then look to solving the problem like we did last class. Okay, so let me just have full size for a minute. With a problem-solving question like this one, the first thing to do is to sketch the information that we have. That sketch is going to help you maybe see a path through the problem that you're not seeing straight away. So draw your axes, use a ruler, but don't mark the scale because it's just a sketch. Now, label information that we have. We're told this. So that means it's going to go through a point here at 0, 10. We're told we have an x-intercept of 1. So it's going to go through here at 1, 0. Lastly, we get this. The x-coordinate of the vertex of the graph is 3. What is this telling us? Which equation is this telling us? Well, what's the equation it's telling us in this information? Axis of symmetry. It's telling us what the axis of symmetry is here in this one. And it's saying the axis of symmetry is here. This is the line. When I say it's an equation, the axis of symmetry is an equation. It's saying x equals 3. That also then leads us to understand the shape of the graph. We can see that the graph is going to go like this and like that. What does that tell us about the value of A? That it's positive. This tells us that A is going to be positive. We just use that to check for errors later. But most importantly, we can go to this point here. We can use the axis of symmetry to reflect this vertex, which is 2 here. So this will be 2 here. So that root, or the x-intercept, is going to be at 5, 0. So now, our first part, A, says write down the value. Write down means there's not really any work involved in this one. The information's right in front of you. So think that when you see the write down. So we have to write down the value of C. What is that going to be? 10. C is the y-intercept constant on all polynomial functions. Now we need to find the value of A and B. This is a bit harder, this one. This is going to take multiple steps for us on this. The best technique for this one is for us to make an equation system. So let's make 2 equations using the 2 roots. We've got the 2 roots here. So this first root of 1, 0 means that when y equals 0, x equals 1. So that's going to give us A plus B plus 10. Our second one is at 5. That's going to give us 0 is equal to 25A plus 5B plus 10 as we put them into the equation here. This is an equation system. We'll use the equation system symbol, and then we'll enter it into our calculator. So menu, algebra, system of linear equations. We've got 2 unknowns, but we press tab. The unknowns are 1. The unknowns are at A, B. So now I can type my equations in. 0 equals A plus B plus 10. Our second one is 0 equals 25A plus 5B plus 10. Press enter, and we get 2 and minus 12. So notice here, inside this bracket, it says A comma B. So A is 2, B is negative 12, and we expected A to be positive as well. So the value of A is 2, and B is negative 12. And then in C, we're asked to write down the second x-intercept, and that is at 5. So I'll just say x equals 5. Look.
I just wanted to know how the second one and the linear system equations.
Okay, I can show that. So for that second equation where I've got 25A, 5b, let me just show you how we're making that one. I went a bit quick there. So we have the function y equals ax squared plus bx plus 10. We know that c is 10 from part A. We are going to now insert this value here. We are going to insert the coordinate 5, 0. So y is equal to 0 and x is equal to 5. If you substitute this into the formula, it's going to look like this. Now, 5 squared is 25, that's what gives us 25a, and then 5b plus 10. Welcome. Okay, have a go at this one, it's a bit more wordy. So with this one, we need to find an equation for the height. I'm going to call the height y. I'm going to call the height y. It tells us here that the perimeter is 260. So for A, we can say that 260 is the perimeter, and that's going to be made of 2x plus 2y. We've got a y here, we've got an x here. If we divide through by 2, we're going to get 130 is equal to x plus y, which means y is equal to 130 minus x. Find the equation of the area. So area is x times y. Area equals x times y. So that's going to be x times 130 minus x. We can leave it like that for now. Plot the graph of your equation showing the area on the y-axis. Choose a suitable domain and range. Let's have a look. So we pull up our graphing calculator. We're going to need to press Control and Page, add a graph. We can type it in as we see it, x times. So some of the functions on the calculator, when you have x bracket something, always add the times in. I know in like AISL sometimes it doesn't like that if you don't have multiplications. So I'll put the multiplication in, we get a graph looking like this. Can't see anything, craziness. So what we need to do is figure out what the suitable domain and range is. Now this constraint equation here says that y is 130 minus x. So the biggest x can be is 130 because y can't be 0. So let's start with that one. Double click here, change this to 130. Still can't see anything. So let's make this really big. Let's make this really big. So if it's going from 0 to 130, then the middle value is half of that. So that's 65. So I'm going to put 65 times 65. And we can see the shape of the graph. So our range is from 0 to 4225, and our domain is from 0 to 130. So we plot the graph. Let's have a little sketch of that for C. Yeah.
What did you do to get the graph here?
What did I?
To the graph.
For the domain.
Yeah.
So what I did for the domain is I looked at the constraint equation and I said if x is bigger than 130, this is no longer positive and lengths are always positive. So I went from 0 to 130 and I just double click on these and I can type in and change the shape. The next thing to do was this direction. And what I kind of had an idea for is understanding the shape that we have is a rectangle. Now a rectangle is at its biggest when it's a square. A rectangle is at its biggest when it's a square. So basically each of the lengths, each of the lengths are going to be all the same size. So you can just sort of say, well, it's going to be at its biggest when it's a square, that would be 260 divided by 4, because there's 4 sides to share that out. So I get the 65. So 65 times 65 is 4225, which is, I thought would be the height of the graph. I don't know if you noticed, but when I typed it in here, I didn't even do the calculation. I figured out it was going to be 65 times 65. And the calculator will take it like that, and then it will cut me up a little bit. So I just want to little sketch this. So our graph is going to look like this. We go up to 130. We go up here to 65, 4225. When it's a square, 260 divided by 4 is 65. So this is going to be when it's square, when we do times x would be 65, y would be 65. The area would be 65 squared. I'm taking a few shortcuts by getting it, but you can just play around with zooming out until you sort of find it, and then find the max, and then you find the max, and then you get that. That's how I expect it.
Just type what you highlight.
Okay, so D, find the coordinates to the point where the graph intersects the x-axis. I kind of did that through logic, but if you were just graphing this and then I think an easy technique is just to graph it and zoom out until you sort of see it like this. Then we can use menu, analyze graph, find the zeros. We can show lower bound, upper bound. We can see that that one is at 130. Menu, analyze graph, find the zeros. Lower bound, upper bound. And that one is at 0, 0. State what these values represent in terms of x. That's the smallest x value, the largest x value, so that this is the largest x value such that y is not negative. This is the largest x value such that y is not negative. Without great negative area, we can't have this. So these are the min and max x values. Such that area is bigger than 0. F. Hence, find the equation of the graph's line of symmetry. There's two ways to find the equation of the line of symmetry. We've seen one way where we find x sim as being x1 minus x1 plus x2 divided by 2. Another technique to find it, if you have it graphed, is by using menu, analyze graph, and find the vertex. So this one has a maximum. So if I find the maximum, I see it's at 65, 4225. If I want to fix this, notice that I'm getting the standard form on this one, and to do with my settings that I have here, if I change this from float 3 to auto, it might fix that for me. No? If I change it from into a higher float, put it into float 4, if you're wanting to see the number, play around with that until you get the information you need. So the equation of the axis of symmetry is x equals 65. State what the equation of the line of symmetry tells you in this context. Well, that tells you the x value that will create the maximum. That will tell you the x value that will create the maximum. So the axis of symmetry is the x maximum value. In more context, that tells you the x value that will make the square, because y is also going to be 65. Okay, our last question, exam style question. Take 5 minutes to have a go with this question. Alright, so this is a very typical exam type question that you're going to come across. This is a question you've not seen before, definitely not seen anything quite like this, and it requires a bit more problem solving in order to achieve. Part A is easy. Part A is very straightforward. So we need to determine the axis of symmetry of the parabola that models the arc. We're given the function here. So there's two ways we can do this. There's two good ways that we can choose to do this. I'll show both. One of the easiest ways is we're going to graph this. So let's pull up the graphing calculator. I'm just going to add another graph page. And I can type in my function minus 1.6 x squared plus 4.48x. And we can see the shape there. Alright, so this is a nice size for us. I'm just going to zoom in a little bit by making this -1. Bring this one across. I'm going to make it 5 or so. I'll bring this up by making it -1. Zooming me in a little bit. I'll go a little bit more here to 3. Lower this one down to 3. No, 4. Okay, I got the graph drawn here now. The easiest way to find the axis of symmetry, as I showed earlier, is to analyze the graph and find the vertex. So if we find the vertex here, we can see that the axis of symmetry is x equals 1.4. So in A, x equals 1.4. There is another technique that I want to share on this one for finding the axis of symmetry, and there's a formula in the formula booklet. If you open up your formula booklet, just find a copy on the Google Classroom. You have the formula booklet here. There's the formula sheet. So this is functions. So functions is going to come in topic 2, the formula booklet. I'm going to roll down. We are looking for here, axis of symmetry. So if you have a function ax squared plus bx plus c, the axis of symmetry can be found by minus b over 2a. Minus b over 2a. Let's just prove that that one works. We want minus b over 2a, so I'll go to the calculator page, press Control divide. We want minus b. Now b is 4.48. 4.48 over 2a, 2 times, and that's negative 1.6. And that will also give us the answer there as well. So that's a useful technique in some situations. Now B is going to take a little bit more, and this is where the problem solving comes in. So what is my first technique I suggest for solving problems? Graphing it, sketching the information that we have. So we already have a graph drawn, and we already have, we've just found the axis of symmetry. So let's put that on. We've got the axis of symmetry at 1.4.
So it says on the determined equation the axis of symmetry. Do we just leave it as x equals 4?
That's an equation. So the axis of symmetry is a vertical line, so it's always going to be x equals something. Always. Don't forget the x equals on the equation. A lot of people put 1.4 down and then they get it wrong. I'm okay with 1.4 here in the graph because I'm labeling this point here on the x-axis. But if you're asked to sketch the axis of symmetry, you need to label it with an equation. Or to ask for an equation, you give an equation. 1.4 is not the right answer. So what's missing from our picture? What's the question about?
We do know to create the theory, so we just find the line.
We've got a square-based crate. We've got a box. Let's put the box on. How's the box going to look? We want the box to fit. It's going to have to look something like this, isn't it? What is the height of the box? So this is 2. Now, will we just push? Obviously, it's not going to be the same as the height here. That's not what we want. Because the box is wide as well. It's not like a stick we're moving through. We could move a stick through at the vertex, but the box has to be a little bit wider. This is why it's problem solved. And that's why when you sketch it, you get the idea that you're not after the maximum on the vertex. Look at the picture. How long does this line here need to be? You're obviously going to get the maximum possibility, you're going to center the center of the box through the axis of symmetry. So half of it is one side and half of it is the other side. You're then going to see, will the function allow it through at that point? So what we need to figure out is how long is that line there? How can we work that out?
80 centimeters.
How did you get that?
This 1.6 wide.
Yeah. So what Alexander is saying is you take 1.6, you divide it by 2, and it tells us it's going to be at 0.8 or 80 centimeters wide on that. So 0.8. So if that is 0.8, what is the x value here? So this is 0.8. What is the x value going to be here? How did you get that?
I added it to the symmetry.
So to get from here to here, we go across by 1.4, and then we go across by another 0.8, and this will get us to this point. So this is 1.4 plus 0.8, and that will get us to 2.2. So this point here is 2.2. How high is the graph when x equals 2.2? How high is the graph when x equals 2.2? So what we want to do for this question is we want to find f of 2.2. We want to find f of 2.2. That will probably get you 1 point right in that so far, because that shows you found this point here. We go onto the graphing calculator, and I press variables and choose F2, and I put in 2.2, press enter. The archway is going to be 2.1 meters high. So this is 2.11. Will it fit? No. So whenever you're doing a comparison, always include an inequality. Say that 2.11 is bigger than 2.0. Always do an inequality for a comparison. This implies it will fit. Now that is a very typical IB question. You've got something where you've never seen anything quite like that before. And what it required was basic common sense. you have the tools already to solve that. We have the tools for axis of symmetry, for understanding a bit of coordinate geometry, for finding the value of function at a point. All those are quite simple tools, but that question presented to you as a very hard question, very challenging question, because you've never seen anything like it. And these are the skills that we need to learn to develop when problem solving. What made it a lot easier was me sketching it, sketching that box there in that particular place, and we see, okay, how wide would the box be? You have to sort of disconnect from the panic of thinking about math to the more relaxing, okay, let me just use common sense. How would I move a box through a tunnel? I'm going to have to put it through the center. A lot of people go wrong on this one, and they fixate on the vertex because they're only thinking math. This question's all about the vertex always. And it's not. The vertex is irrelevant for us in this one, apart from the axis of symmetry. Alright, that's it for